Okay, after
Music on the phone down.
Yeah, it's live. Let's pray. Heavenly Father, we thank you for this day. Pray, Father God, for understanding in Jesus' name. Amen. This is C. This is 1 meter. This is D. E is an upward force. Yeah, 2 meters. And 9 kilonewton. Where? This was in 28. Okay. Yes. Okay, so BSc N5B 1.9.1. Calculate the value of the reactions RR at RL and RR. Here I'll be fast because already ready. Wait a moment. Okay, so I'll be fast on it. But you need to know, okay, for now. Okay, so we'll be using a 1 for a second. I just here, going that direction. This is clockwise. And then opposite direction, the arrow should go opposite each other. This is anti-clockwise. We have clockwise, we have anti-clockwise. Clockwise, below your second. Clockwise, above, it is anti-clockwise. They should oppose. Clockwise, anti. Okay. Another thing before you can calculate, some other people don't do it again, Mara. I suggest for we do it. Some people, when calculating, let's say RR, they will take that UDL multiplied by that distance, multiplied by half of that distance. So I don't want us to do it that way. So the first thing that we need to do, it is to change, number 1, change UDL to force. How you can identify a UDL is that it has kilonewton per meter, and a force is kilonewton. So we are converting from kilonewton per meter to kilonewton. So we have 7 kilonewton per meter there. It starts at A until at D. How you can identify a UDL is by the SI unit, which is kilonewton per meter, and also when you see it shaded. It can be shaded in different ways. As you can see here, it is shaded using lines, then this one using crosses. Yeah. But they are all UDLs. We have 7 kilonewton per meter. We also have 9 kilonewton per meter. So we'll start with the 7 one. When you change UDL to force, you change it by saying the UDL, which is 7 kilonewton per meter, you multiply by the distance that the UDL has covered. The distance covered. It is the UDL multiplied by the distance covered. So here is our UDL, it's 7. What is the distance that the UDL has covered? It's from A up until D. So I'm going to count. It's 1 plus 3, which is 4, plus 4, which is 8. So it means that the UDL has covered a distance of 8. So it's 7. It is 7 kilonewton per meter multiplied by 8. What's the answer? 56. So this 56 is no longer kilonewton per meter. We have now converted. We no longer have a UDL. We now have a force of 56 kilonewton. We have two UDLs, it's 7 and also 9. So now we're going to the 9 one. It's 9 kilonewton per meter. You multiply by the distance covered. You multiply by the distance covered. So we have 9 kilonewton per meter, which is the UDL. Multiply, what is our distance covered? 9 covered which distance? It's 1 plus 2. Here is our UDL, it's 3 again. There's 9 times 3. What's the answer? 27. So we now have 27 kilonewton. We no longer have UDLs. So now the first thing it was to convert from UDL to force. Number 2, it is for you to place your force, your new force. Place your new force. You're placing your new force in the middle of the distance. In the middle of the distance. You now need to place your new force. Your new force is 56 kilonewton and 27 kilonewton in the middle of the distance. What do we mean by this? 7 kilonewton per meter is covered a distance of 8 again. So when you have a force, when you've now converted, you have 56 kilonewton. You need to put this 56 kilonewton in the middle of the distance that the UDL has covered. Again, UDL has covered a distance of 8. So the middle of 8, give 4 again. So the distance is equal to 8 divided by 2. This is for the 56 kilonewton. Distance is 8 divided by 2. Again, the area has covered 8. So we need to put the force in the middle of 8. So answer it's 4. So let's count 1, 3 is 4. So right here where there is 56 kilonewton, it means we're going to have, when there is 52 kilonewton, it means we're going to have 56 kilonewton. Again, so we're going to say and 56 kilonewton. Right here on this end. To avoid us making double errors here, so let's just say it's n. We know that, oh, here on that letter C, we have two forces, 52 and 56. Now, let us place the other force in the middle. What is our force? It's 27 again. So for the 27 kilonewton, what is the distance? Remember, we need to put it half of the distance in the middle of the distance that the UDL has covered. Our UDL has covered a distance of 3. So it's 3 divided by 2. What's the answer? 1,5. So let's check. We are not allowed to move this RR. RR is a reaction. You are not allowed to move reactions. However, you can work around the distances again. So we have 1,5. It means that this 27 kilonewton should be where there is 1,5. Here there is 1. Our UDL cannot be there. We have 2 here. So let's say 2 minus 1,5. 2 minus 1,5. What are we getting? 0.5. So it means instead of, let me write this 2 here, instead of us writing 2 here, we can say this is 1,5, this is 0,5. The distance does not change. From RR to F, we still have 2. 0,5 plus 1,5, it's still 2 again. So it's still 2. So that is how you do it. You are not allowed to move the RR. Okay, so again, someone would say, oh, here I have 1 meter and it should be 1,5. Let me just add 0,5 this side. It's not allowed. You would have moved the RR again. So that's not allowed. Say, Robin, here, 1 plus 0,5 gives you 1,5. So your new force will be, somewhere there. So let us just draw another diagram. So let's Thank you, very good. So we're not going to draw a beam that has no UDL. Okay. So this is an A. We have an upward force which is Rm. A distance of 1 meter, this is B. A distance of 3 meters, this is C. 4 meters, this is D. 1 meter, this is E. 0.5. Here there is RR, and then 1.5. This is F. I did it correctly, Muslim. So here we have 27 kilonewton. Here we have that 28 there, 28 kilonewton. At D there is nothing. C, we have two forces, 52 and 56 kilonewton. We have 14 kilonewton. It's correct again? So we have moved from the beam that they gave us to a new beam. How do we get to this new beam? Your new beam should only consist of forces, and we've already changed from UDL to forces. Let's check. We have RL there. This is your RL. It's 1 meter. You have 14 kilonewton. There is your 14 kilonewton. We no longer have a UDL. Why? Because we have changed the UDL into a force. How did we do that? UDL multiplied by the distance covered. Then you take that distance covered, you divide by 2, so that you'll be able to do what? To place your force. So we found out that it's 56 will be here, straight at 4. And there was already a force. So what did we do? 52 and 56. We know that here there are two forces. Then 4 meter. DD. We no longer have a UDL of 9 kilonewton per meter. It is now 27 kilonewton. There is your 28. That did not change anything. What I only changed is the from UDL to forces. So that is how you do it. So now we are going to calculate RR and RL just like the question asked us to do so. So we're going to take moment about RR. When we take moments about RR, this means that all forces are meeting. There is a meeting at RR. Once you say that you are taking moments about RR, here's your RR. All the forces, this force is going to meet there, this force is going to meet there, this one is going to meet there, all your forces are meeting at RR. That is what taking moments about RR means. So when you are taking moments about RR, you can't be looking for RR, meanwhile all your forces are meeting at RR. If all your forces are meeting at RR, it means you are looking for RL. If all your forces are meeting at RL, it means you are looking for RR. So it means here we are looking for RL. So what is RL? What is the distance? Here it's force multiplied by the distance. When you calculate RR and RL, it's force times distance. So from RL, we said when we take moments about RR, it means that all forces are meeting here. So from RL to RR, what's the distance? 1 plus 3 plus 4 plus 1. What's the distance? 9. So it's RL times 9. Let's check the direction that RL is moving at. Here's our RL. Here's our RL, the upper force is like this. It's meeting where RR is going like this. Is this clockwise or anti-clockwise? Clockwise. So it means now I'm going to look for any other force that is going clockwise so that we can group them together. Again. So now that you know, before this, you will skip a line there again, and then after knowing this force is clockwise or anti-clockwise, you edit there. This is sum of clockwise movement, which is equal to sum of anti-clockwise movement. It means on your left-hand side, you will include the clockwise movement. On the right-hand side, you will include the anti-clockwise movement. However, this step is difficult for you to do if you have not checked for it, whether RL is going clockwise or anti-clockwise. That's what I'm saying. After take moments about RR, you will skip a line again. Then you write what? RL times 9. Then, RL is going clockwise. So this means on my left-hand side, it is the clockwise movement. Okay? So let's check any other force that's going clockwise. This one, it's, okay, let me erase this. We have 14. 14 is a downward force. It's going like this. It's going to RR. Is this clockwise or anti-clockwise? Anti-clockwise, okay? This one also is a downward force. This is how it's going. It's going to RR. Is it clockwise or anti-clockwise? Anti-clockwise. What else? We have 28 there. 28. Is it going clockwise or anti-clockwise? It's clockwise, however, we are not going to include it because it's ending straight on RR. So the distance will be 0. So it's 28 times 0 again. But let us just edit for knowledge. Plus 28 times 0. Okay? Even if you don't do it, 28 times 0, I also say, okay, let's check. 27. This is 27. Let us look at the end. It's going at RR, right? Is this clockwise or anti-clockwise? Clockwise. So plus 27 times, what is the distance from 27 to RR? It's 0, 5. So times 0, 5. So we have now grouped our clockwise movements again. Now we're going to the anti-clockwise. We have 14 there. Let me erase these mirrors. Okay, so equal to sum of anti-clockwise, we're going to start on our left. It's 14. What's the distance from 14 to RR? 3 plus 4 plus 1. 3 plus 4 plus 1, it's 8. And then plus 52. What's the distance from... What had I written here? There was nothing. More like emoji. There's some other stuff. Okay. So it's 52. What's the distance from 52 to RR? 4 plus 1, it's 5, so it's 52 times 5. Here it's first times distance, let's check. 14 is a fourth, distance is 8. 52 is a fourth, distance is 5, so it's first times distance here. So plus, what's another first? 56. What's the distance from 56 to RR? 5. So 56 times 5 plus the complete again. Okay, so let us quickly add. On our right hand side, what's the answer here? What's the answer? But I already did it just plus 13.5. Okay, the right hand side. Right hand side. We have 708, and then here RL times 9 will be 9 RL. What's 28 times 0? 13.5. What's 28 times 0? 28 times 0. Yes, 0. Plus 0. Plus what's 27 times 0, 5? 13.5. Let's say the question. Let's come on. Let's see. So now, here we're left with 9 RL.
Oh, 708.
Ubrilla 708. So why is that? Ubrilla, I mean, I'm also Ubrilla. 652. 652. Who is it? 652. Calculate that. I got 40 times 8 plus 52 times 5 plus 56 times 5. So it's 9 RL. It's 9 RL like that, and then equal to. You can't add 9 RL to 30.5 because they're not like 10 again. 30.5 will jump the sign. So here we have 652 minus changing the sign 13.5. What's the answer?
638.
638.5. Then we divide by 9. We divide by 9. What's our RL? Let me get you more. Very high. What? Got one last sound. Hello, are you able to hear? Problem la yakho ifane comment. Okay. So what's the answer? 70.94. Okay, so our RF, therefore RF is equal to 70.94 kilonewton. We are done again. Let's go to RR. Now we are going to take moments about. We take moments about RL. What does this statement mean? All the forces are meeting, all forces are meeting at RL. And as Mukona said, we are calculating RR. So RR times What's okay? And then this one, you don't have to skip a line because already on the other side, you said it's a sum of clockwise movement again. This one will be the opposite. You can't start with sum of clockwise and start with sum of clockwise again. So it's sum of anti-clockwise movement, which is equal to sum of clockwise movement. So it's RR times the Michigan RN. So let's check from RR to RN what's the distance? 1 plus 4 plus 3 plus 1, 9. So it's RL times 9. Let's check. RL is an upward arrow and it's going that side. Is this clockwise or anti-clockwise? Anti-clockwise, okay? So let's check at any other force that is going anti-clockwise. 27, clockwise or anti-clockwise. 28, clockwise. So it's 28 times, what's the distance? Oh, yeah, it's anti-clockwise, okay. And then what's another force? 52, clockwise, 56, 14. So it means RR times 9 is the only one that's going anti-clockwise again. Okay, so we start with 14. 14 times from 14 to RL. Again, this is RL 14 times 1. And then plus 52 times, what's the distance from 52 to RL? 4. So it's times 4 plus 56. 56 first times the distance to RL? 4. 56 times 4 plus 28 times 28 times 9 plus 27 times. It's 9 from here to there, 9 plus 0.5, 9.5 again. Any other force? No. Let's calculate what is the right hand side giving you. Here it's 9RR. The right hand side is 954.5. Huh? Don't you include RL? And then what's the answer? 954.5. Divide by 9. Divide by 9. What is our RR?
106.
What?
106.06.
106.06 kilonewtons. If you add up, you can't add up anywhere because the main purpose of calculating RN and RR is for you to prove that the sum of clockwise, the sum of upward forces is equal to the downward forces. So if now you included a bargain, you included the RL, your number will be too much. No wonder you can't add something else, it means there. We don't do that. When you're looking for RL, you don't include RR. When you're looking for RR, you don't include RL. So let us confirm. Sum of upward forces is equal to sum of downward forces. Upward forces, you look at the arrows. There are only two upward forces again, which is RL and RR. What is our RL? 70.94 plus 106.06. And then what's the downward forces? 14 plus 52 plus 56 plus 28 plus 27. Left hand side, what's the answer? 176, comma?
995.
And then the left hand side, right hand side. Come, you are getting 176.995. Hold 177. And then the other side, 177. Therefore, your upward forces are equal to your downward forces, then it's okay. 1.2, what are they looking for?
Determine the values of the shear force at each intersection. Draw the shear force diagram and set all the values on the diagram.
Okay, 1.9.2, determine the values of the shear forces at each intersection. Draw the shear force diagram and set all the values on the diagram. 1.9.3, calculate and draw the bending moment diagram and set the value of the bending moment maximum in the diagram. So 1.9.2, we'll be doing shear forces. So remember the shear force? It's 1.9. 1.9. Okay. So when you're doing shear forces, we'll be dealing with forces and the distances. Okay, well, there is going to be shear force at A. Shear force at A, what is A? This is A again. Shear force at A, what is the force that is acting on A? 70,9. It's RL. The force that is acting on A, is it positive or negative? So we are going to say shear force at A is positive 70,94. Again, that's how you get the shear force at A, positive 70,94. Shear force you write with the sign. Again, if it's negative, be negative. And then let me check. Shear force at B. Do we have B? Yes, shear force at B. What's shear force at B? Shear force at B? Negative 4. Negative 14. Okay, that's not how we do it. Like, when you're doing shear force, like, let us look at this one. This one here, A, the one that has the UDLs, okay? So let's look at this one here, UDL. It's going to be shear force at A, which is positive 70,94. Then you can't skip to B. Why can we not skip to B? There is a force that is happening here, that is 18 there. There is something that's happening there, okay, which you should include in your shear force, okay? So you have shear force at A to B. You don't just jump to B, okay? So shear force at A to B. As you can see, there is something, like what I mean, okay? So there is shear force at A to B. Shear force at A to B. You start where you started. What we need? Rn, which is plus 70,94. And then what's the force that is acting in between A to B? A to B. 14 is at B. I'm saying A to B. The force that's acting at A to B. Huh? Never mind. They train separate of things. Shear force at A to B, is this not a UDF? Shear force at A to B, do you as a UDF? Huh? As a UDF? I just said when you're doing shear forces, I will lay that diagram you're going to be I can write this and focus on it. But if you focus there won't be any shear force at A to B. I can there's nothing.
So I just calculate and then I can do the diagram again.
Huh?
I'm talking about that question whether you end that diagram as your first.
We are come on. We
What is
we just arrived.
the draw? I was saying calculating.
We are dropped that one. You must You guys want to Okay. So shear force we can't look at this diagram because when you look at this diagram, is there anything happening between A and B? No, again. So let's look at that diagram that they gave us again. So shear force at A to B, there's a UDL. As a 14 is at B. A to B. When I 14 no. 14 is at B. Remember at A to B. Again. So at A to B, come on. So now we're going 56 and a half.
7 times 1.
Even though no, from A to B. I don't wanna read the area like it's 18 from A and up until D. I get so commonly UDL. So looking at that UDL from A to B, there's a UDL. People can UDL. What's our UDL? It's 7. So more or automatic. First, that's 18 at A, which is positive. Again, 7 here is it negative or positive? So you subtract 7. 7 again, here UDL again. And then what is the distance here UDL from A to B? 1. So it's 7 multiplied by 1. You started A. Maronyaka from A to B. So from A to B, there is a force that is happening there, which is the UDL again. So UDL multiplied by that distance from A to B. Yes, we know that UDL here now the distance is not 1 again, but you want the shear force at A to B. You can't say the distance at A to B is the distance of the UDL. It's wrong again. Ujia, the distance that is 18 from A to B. So it's minus 7 times 1. What does it give us? 63, comma 94. Okay, more than kilonewton again. And then shear force, we have shear force at man now. Shear force at B. Yes. Shear force at B. So shear force at B, what do we have? It's positive 70,94. We start at the beginning again. We start at the beginning with 70,94 and then minus 14. Before I think I would be, I want to say minus 7 times 1. Minus 7 times 1. More shear force again. Someone else can say, I'm just taking this number, I'll continue.
So basically, whatever happened previously.
Yes. Positive 70,94 minus from A to B, you have 7 times 1 again. And then now the minus of that. Minus 14 or minus 14. What's the answer?
So only UDL is multiplied by the distance.
Yes. Huh?
Shear force A to B.
Yeah, I got to me fast. Again, I told you that you can use this one. So when you told me we'll use it. Again, it's allowed. It's not wrong. But now I want us I want us to start here so that you really understand what's going on here. Again, Mara, you can use that one. I use that. 49,94. Positive. Let's start by the side. Plus 49, comma 94. This is
So even the answer will be
yes. Yeah, positive even if you don't write Mara, negative, you will write Mara. Yeah. So now we have shear force at 1. This is shear force at B. Now we're going to shear force at B. Okay, what was shear force at shear force? We're dealing with forces only. It's forces only. However, for the UDL, until UDL, remember it's not a force. And for you to change from UDL to a force, what do? You multiply by the distance. That is why more the UDL here now will be multiplied by the distance. Shear force is forces only. However, kilonewton per meter is not a force. Okay, so multiply it by the distance. So now we got 49.94 again. Then shear force at B to C. Again, we are at shear force at B. So now we are going to shear force at B to C. You can't go to shear force at C because from B to C there is something that's going on. Again, so at the beginning, I will start at the beginning, positive 70.94, and then
minus 7 times 1.
minus 7 times 7 times what? Okay. Where are we now? We're looking for shear force at what? At B to C. Okay. We're looking at shear force at B to C again. Okay. When I look, okay, yeah. The problem with sometimes using this one is this one right now. Let's check. It's shear force at B to C again. Shear force at B to C is from here up until there, right? It's the shear force that we're looking for now. But I'm saying, when do we start at A? Again? So at A we got 70.94, which is an upward force, imported here. Now we want to subtract. From B to C, there's a UDM going on, right? It's 7. The distance, you will not say the distance is 1. Again, you are going to say the distance is 4. Because we started when at A. So from A to B, what's the distance? 1 again. From B to C, what's the distance? And the UDL look like it's 7. Again, the UDL started A. So it's 7 multiplied by 4. You will understand them once we are moving 7 times 4. And then minus 14. It's downward force minus 14. What's the answer? Huh? 28. Positive. Positive 28, comma 94. Okay. Before we continue, let's start again. Again, we're doing shear force. And I'm saying shear force is forces only again, but when it comes to the UDL, it's the UDL multiplied by the force because the UDL is not a force again. Okay. So, alright, shear force at A. This is shear force at A. It is the force that is acting at A or on A. Again, so here's our shear force. We have a force at L we got, oh, I've written it there. It's 7.94. So the force that is acting on A, it's an upward force. An upward force means it's positive. Again, so there's our shear force at A. We are done. Okay, we go to shear force. We can't jump to B because from A to B there is what? A UDL. And that UDL is 7. What is the distance from A to B? Or what is the distance that your UDL has covered from A to B? It's 1. Again, so it's minus because it's a downward force. Again, if it was a positive, note or plus. So it's minus 7 times 1. Then it gave us 63.94. We're now going to shear force at B. At B there is a force that is acting there. It is a downward force. Again, we start at A. So shear force at A, it is 70.94. 70.94 minus what? Still from B, when you're at B, what's the UDL? What's the size of the distance that the UDL is covered? Q1. That's why still more. We said it's 7 times 1. And then at B, what's the force that's acting at B? Q14. Again, so it's 70.94 minus 7 times 1 minus 14. It gave us 49.94. Then we go to shear force like B to C. We start at A. We start at A. So when we start at A, it is what? Shear force at A, from shear force at A, which is 70.9 for the force that is acting at A, then minus 7. The UDL is 7. The UDL is acting from B to C, so it's 7. However, that 7, you don't say 7 times 1, then 7 times 3. You're going to start at the beginning. The UDL has covered from A to C, so the distance is 1 plus 3, which is 4. And then remove B to C again. We are not yet at C, so you don't use this force that is acting at C. You are using the forces that are backwards again. So minus what? Minus 14. And then is there any other force that is acting between A to C? Between B to C? No. So it means that then shear force at shear force at what? Okay, then let's do something. What's the nothing I'm gonna get. Shear force at C. Shear force at C. Shear force at C, how are we going to do it? We start from A, you are right. Positive 70,94 minus 7 times 4 again. Minus 7 times 4. Omwa continue. Yabama, Shalom. Minus 40. Minus 52. You feel like minus 56. Why you feel like more than 56?
I need the 56 there, icon with the end on. I'm not going to icon of 56.
What? Huh?
56 is the
First.
yeah, but before
Oh, yeah, yes.
it was your result of the
Yes. I shall fail. So 56 here, it is a result of the even then let us erase it. Again, we better check. We'll use it again.
So we completely go back to that structure and don't choose whatever we have.
Yes, darling. Yes. And then 52 again. It is our bright peg. Negative 233, 0.06. Come on, you get the answer. Now we are going to check what's that? C to D. One of us, there's a UDL. Shear force at C to D. And then your positive 70,94
Minus 7 times 8.
minus 7 times 8. Let's show me 8. Okay, minus
Minus 14.
minus 14. Okay, for the ones that don't understand there, it's again shear force at C to D. So we start here at A again. We said it's positive 70,94 is our RL, and then minus because it's our UDL. UDL is negative again. So 7. What is the distance that the UDL has covered from A up until we are at D again? Up until D. It is 1 plus 3 plus 4 plus 1, which is 8 again. That's why we said negative 7 times 8. And then another force is 14. Then minus again, the minus like minus 52. That's the force that is in C. And then are we done? We are done. Okay, answer.
Negative 51,
-51,06 kilonewton. You understood it? You shall. Okay, shear force at D. There's nothing at D. Like what? Or like one or something next I want it. At D there is nothing. Straight. Huh? No, at D there is nothing. There's no force that's acting here. Look. At C, there was a force here with a muscle. Again, that's why we calculated at C. If at C there was nothing here, you wouldn't calculate shear force at C. You would calculate shear force at C to D. I don't know if you get me. Shear force at C, there is nothing. Again, Marana, you're on. Normally, what? 14, again. 52. Shear force at D, there is nothing. There is no force that's acting straight at D. You cover shear force at D to E. Like, hey, I'm not force that's acting at D. So shear force at one of those to shear force at E. At D to E. Shear force at D to E. What's shear force at D to E?
Shear force at each is going to be
plus 70,94
minus
Give me a message. Maybe kids or something.
times 1 minus 28.
Okay. Okay. It's looking. It's 70,94. 9 is minus minus
9 times 9. 9 times 1. 9 times 9.
where is the 9 coming from?
It's a UTL.
Huh? So it's positive 70,94 minus
9
this 9 going and UDL.
times 1
9 for the UDL times
times 1. 9.
9 times 1.
9 times 9. I got some from
Get 9 times 9 times 9 because it's automatic 8. And then you go 9 times 1. 9 times 1. 9 times 1 is
It's the distance between here.
okay, and then you feel like so. You feel like Lily, you feel like you from guys. You from guys.
7
Hey, you know what?
it's 61.94.
61,94. You first got 9 for keep thinking 9 times 1, I'll get 9 times 9.
9 times 1. 9
And then you have 9 times 9 for what?
negative 10 minus 0.
Book on now? General. Share percent E and D to E in general.
We have a positive 70,94.
So, hey, that's a general son. That's a general family. Okay.
Positive
90.
70,94.
In general. And then
And then minus 7 times 8
7 times 8
minus
minus what?
minus 14
Minus 14
minus 52
minus 52
minus 9 times 1.
minus 9 times 1. Yes, General, what's the answer?
One card.
Yes,
Minus 62,
From A to D.
Yes. When you go to the discussion from
I thought maybe it should from A to
A to E, minus 7 kilometers per meter, you be any I think you will that's what it's about. What if any answer general?
minus 60,06.
General is correct. But general, General is very correct. Is 60, negative 60 come on?
06.
06. Okay, I'll try the same, I guess. Share force at D to E. Share force at D to E. We are here. Again. So let's start. We're starting here. It's 70,94. The one at RM. I get positive. Then minus. What is our UDL? From A. Okay. What's the next force? It's 7 again. The next force is 7 kilonewton per meter. However, 7 kilonewton per meter, how it starts at A up until D. So it's 7 times 8. I know the distance from A to D is 8. So it's 7 times 8. Then you move, what's the next force? Give 14. Again, after 14, you subtract what? 52. After 52, it's 9. Again, from D to E, we have a UDL, that is 9. So 9 times what's the distance between D and E? It's 1 meter. So that's why I'm correct. And then try to explain yours for me. What are you trying to do?
When
Again, the lyric 9 times 1 and leave 70,945.
oh, it's because I did our UTL starts at D.
Yes.
So that's why we were saying really it's going to be 70. Which is what's the 70 from?
70,945. Okay, okay.
It's going to be 7.94 meters.
It's incorrect because you skipped all those answers there. If you had given us a force, maybe RR, then maybe, just take over RR, just think of RR, how can we use it? Huh? Hey, so that one, when you use RL, it's incorrect. When you use RL and then the force, you jump the UTL. From A to up until E, there are forces that are acting there, and when you just put them, it's incorrect. Like, so you don't do it like that. Yeah, we can use it, but not here. In future, maybe after D2, the other side. Yeah. So now it's shear force at, can we move it? You understand it? Shear force at, shear force at E. Okay, give me the forces. 70,
94
positive 70,94
minus 7 times 9.
minus
7 times 9.
7 times 9 is 1. 9 is 9. How did you get to 9?
I say from it's from A to B.
Yes, it's from A to E, but your UDL 7. Is it there on E?
Oh, yeah, so times 8. And then minus
7 times 8
minus 14
minus 14
minus 52
minus 52.
minus 20.
Minus 52
Monday,
minus
minus 52 minus 28.
minus 52 minus no, minus
Minus 28 times
where is 28? Oh, at E. If the first acting at E. You feel like
minus 9
minus 9
times
times
1.
1. What's the answer?
88,06.
You got
Negative 88,06.
negative 88,06. Okay, so you know that when I should at E, the way it's calculated. It's negative.
Negative 88,06.
No, that's how you correct again. Negative 88, comma 06. Let's stop writing again. We'll come back and write. I will not do it. Then shear force at. We were stopping here. Shear force at. Shear force at Magna. At E to F. Okay. Hint ka shear force. Your last shear force should give you a 0. Okay. If I offer 0, you are incorrect. So shear force at F, E to F. Okay, give me the forces.
Plus 70.94
Plus 70,94
minus 7 times 8
minus 7 times 8
minus 14
minus 14
minus 52
minus 52
minus 28
minus 28
minus 9
minus 9
times
times 3. 3 to by
it distance
E to F.
and it distance UTL.
Alright, 3. And then, are we done? What's the answer? So we are calculating from E to F. Ne?
Mm.
Kini. Kini. Yimoga. Never tell me what I
We add up.
can you calculate which was from
Add after 9. Times 10. Calculate me good one.
yeah, right. That is for wealthy people, like wealthy much
Because
it's what? What's our
it's going
What's our
it's 106,06.
106,
6,06.
okay, more than substantial and up. Why is that better? Or any board?
Iti come pure then.
And then you add the up. Ligram ka? Gram mo ya in. The one ya in. Yeah, this one you said it's 0. Next I added this one. So now you're right. So I want the new answer. I think that's 88. Come on, what is it giving you?
Big number.
It's 18.
18. So the difference between number and filler on any negative 88. Kim guy 18. 18 kilonewton. Let's check if our skipper see. From D to E, and then at E by D to E. Why can't we calculate here D to E, JP?
Then why you want to learn about it?
Which one? This one. It's not working, this one. Okay. So this is shear force at C. After shear force at C, it's shear force at D to E. Shear force at D to E, there's a UDL there. Okay, we included it. Shear force at E, there are two forces that are acting there, and we included them again. Again, the 28 positive 106,06. Okay, and then shear force at E. Then our shear force at E2, there is nothing here. Move, there's nothing. And then shear force at E2. Shear force at E to F. At F, is there any force that's acting at F? Yuma. At F, there is nothing. Can I see a diagram? Okay, at F, there is nothing. Okay, so yeah, we'll do a call. Okay, copy that. Okay, sorry, wait. Shear force at E, there are two forces that are acting there again. At E, there are two forces again. So when there are two forces like this, because Emma, again with the question that we should draw a shear force diagram. When there are two forces, put over force more, and then again we are extending power force more again. So then according to the way we calculated, that won't happen when we do our diagram again. So we need to calculate shear force at E 2 times because it has two forces. If you get a place, a letter where it has there are two forces that are acting there again, you calculate it 2 times. Why 2 times? The first one will provoke a delay one force, the other one will provoke a delay the other force. Now, so let us just edit around the again. You will give me this one again. Here it's shear force at E. When you don't add 106,06, what are you getting?
As long as you were right.
It's not correct. That's right correct here. It's not. Let us calculate it again.
It's going to be set plus 7.94.
Let's start. It's shear force at what? At E. Again. Shear force at E.
Araba.
A. Then above after D to E.
After D to E.
Yes. Again, I'm saying, for you to draw the shear force diagram, you draw, if it's on letter E, there will be 2 points on letter E. So the way we did it, there won't be 2 points. So shear force at E, atomic. Shear force at E,
Positive 7.94 minus 7 times 8 minus 14 minus 15.
let's start positive 70,94. Yes.
Minus 7 times 8
Minus 7 times 8.
minus 14.
Why are you not literally to my minus
14
minus 14
minus 52
minus 52
minus 9 times 1
minus 9 times 1
minus 28
minus 28.
equal to
Shear force at what? At E.
You don't subtract 28.
Subtract what? We don't subtract 28. Also subtract 28. What does it give you? Tell it down, oh. Then subtract the rest. Look at that.
Negative 60 plus 06.
Negative 6,06. Okay.
It's not really as a subtractor. This one is a
Look on.
What is a subtractor?
Look on.
What is subtractor?
Look on. Ya kana kala na. Kuri wena nyeke shear force at E mara usa subtract before saying remove E.
Minus 28,
Comma.
28.
It's either uto plus or minus 28. One of the forces one choose again. Okay, so let's add 106,06. Here, Papa. 46. Level of force here wasn't here. So here we draw a real order. When there are two forces that are acting, we'll calculate how many times? 2 times. The first one will go one force, the second one will be the other one also. So shear force at E, let's calculate it again. Unit 5.
7 plus 70.94.
Positive 70,94
Minus 7 times 8.
minus 7 times 8
Minus 14.
minus 14
Minus 52.
minus 28
Minus 28.
minus 28
Minus 9 times 1.
minus 9 times 1
Plus 106.06.
plus 106.06. Get back by
Positive 18.
positive 80. Someone else could have said 56, 46. Yeah? Get your back.
56.
46 minus 28, then come back. Did I 46 minus 28?
46 minus 28. 18.
Yeah. So it's positive 18 kilometers. Why am I confused? Nothing.
Mase amele iranga yini?
Ngokufika leyo element kube le minus.
This one.
I can reduce the edging. But the other one is subtracted.
But
Why
you
do
mentioned
you
it.
subtract then? There is
Move more minus.
it's 2 forces acting on it. Every time there is something like to minus and take it. Maraka you are at that side.
That's another.
At the one force.
This one also 81 percent.
So I'm saying why do we only subtract on the
Here's something that an 8 days of minimum. Since the 106 already, but I can do it this way. More,
Ukona aya B2E.
I think more confused about it. I don't know what.
Ano kumbexani mirhi loko hi ri na ti-secondary eight ta ku ka point yin'we hi rhanga hi endla fossil ya yin'we ivi hi tela leyin'wanyana
Leswi vulaka swona.
Eh,
Vona
vona
loko B2E answer already said kumbe swi loko a hi lahlela yi kuma futhi.
but at E, chef was at E. Revenue 28, 106, more revenue 106, 28, so then Ramu E. Who E? When I 28, 106. 106 already more than we were exchange. So now, the other one.
se mhani kumbexani va ku laya a ni sungule hi tirhise 106 loko hi ta ka xitepe lexin'wana xa hi tirhisa 28
106 are interest.
Leswi vulaka swona.
If we do the way around, we not how to get again.
Swi vula ku ti-answer letimbirhi loko hi subtract answer liya na loko answer ya B2E na ya answer ya E yi fanele yi nyika one of the answers.
Bona, I get chef was at 8, you included 106 fed, and then this one was related to 28 fed again. There are this step and this step, they are the same. The only difference is minus 28 again. So you can just say 46 kilonewton minus 28. You don't have that.
se loko no va ni tirhisi ka lexo swin'wana step ni tirhisi i le ya 28 ke
You have I have 28 minus 28. There are you have a negative 60,06 minus 28. You have that.
negative 88,06
Up to the result, yes. Chef was at E to F. We didn't. Shalom. 70. Positive 70,94.
Minus 7 times 8
Minus 7 times 8.
minus 14
Minus 14.
minus 52
Minus 52.
minus 9 times 9
Minus 9 times 3. Remember, we are at E to F again. When we are at E to F, our UDL, the distance here UDL is 1 plus 0.5 plus 1.5 is 3 again. So that is 9 times 3 and then again we're at E to F and the UDL we will exchange in 9. 9 is covered with distance. Yes, and then can one has a 9 in the window again. Over confused and then minus the minus or the plus
minus 28
28
plus 106
plus 106,06. Or you can use it the difference in movement times 3, right? And answer 0. Now, I should give you 0. So we are done with shape. Did you understand the shape? Okay, so now we need to draw the shape.
The shape was at the end must give you 0
Yes.
at one end or both ends.
Both ends is wrong. At A and B. Mara, at shape was at A is the other end. Regardless of 2,94. So, Jean, you are the first 0. Recover break.
Oh, see, because at the end, the class is class as you.
Multiply by 0, John. Yeah. Okay, bye. Thank you for joining. It's me to save now. Hey, I want to save it. How do I save here?
ina gari ya YouTube